Hey, welcome to my channel again in the Smart Podcast. Uh, this is the channel descriptions about my channels. It is previously uploaded and I'm uploading the series of the Pythons for project videos of particle sum optimizations. It is the lecture 4 videos of the series of particle sum optimizations. In this previous video, I just discussed with you about coding particle sum optimizations in MATLAB environments. It is about the coding before and it is a coding we successfully run in here. So what we will do next? Using the particle sum optimizations to optimize the network of artificial neural networks. I mean actually the neural networks where I'm training the data with some benchmark functions as well as I'm training the same data with using the particle sum optimizations concept when the networks are using the particulars training and learning functions to learn the networks. That time instead of using the training and learning function, I'm using their particle sum optimization to train the data. So if you want to go forwards with the project, so you need some basic ideas about the particle sum optimizations, whatever I discussed. uh, Now we need some ideas about artificial neural networks. So let's come here. What is artificial neural networks and its neural networks? Artificial neural networks. Let's first start with the neural network. Neural networks nothing. It's inspired by the biological neural networks and the working formula as well as biological neural networks. And from neural networks, we create some of the other neural network which is artificially working principle as well as the biological neural network, and this neural network known as the artificial neural networks. And nowadays the demand of artificial neural network, deep learning and machine learning is very high. Those are very trending subject. So if you go forward with them, then obviously I think future 20 years will be very satisfied with your job domain also. So let's go to starts with the new concept of artificial neural network and neural networks. So this is the basic descriptions that I created here. Artificial neural networks that read the descriptions that is highly connected. Neural network is a highly connected network. Why is it highly connected? I will come to it later. And with the number of nodes, okay, called neuron. These neurons is work as in like biological neural networks and work information processing systems. Artificial neural network is inspired by the biological neural network and the working formula as the neural network was based on some logic. The collective behavior of neural networks like human brain demonstrate the ability to learn, recall and generalize from the training pattern or sets. These are the basic concepts, the basic descriptions about the artificial neural networks. Now we go to the diagram, the basic diagram of the building block of the artificial neural networks, what it looks like and how it's work actually. That is the basic building block of artificial neural networks. Okay, artificial neural network. This is the basic pictures of the artificial neural networks. You can see here. I draw the pictures in the Draw.io, right? Draw.io websites. You can draw it in the Max also. Both are good. See, as human beings, what happens? Suppose let assume that is the completely as a neuron. So in neurons, what's happened? The impulse is or the information is taken from the dendron, and the information is comes, and the information is modeled with some synapses, and the information is going to the axons body, and the axons body there is another thing is added with that. After that the information is going to through the axons and it's fired to the next neuron, like one by one neuron carrying the informations, and the informations is going to the central processor hub in our brain, actually in our brain, and from there the impulses come, and what type of decisions will take It will take that type of information is processing in the central hub in our brain. So like this, as a human neuron or axon is doing the thing same, here the artificial neural networks as a single node is doing the same thing here. Suppose those are informations, I mean input is coming. There is a number of input x1, x2, x3, x4, like this number of input is coming, and the input is added with weights. Why weights? Like in biological neural networks, where the information is coming, the information is modeled with synapses. Here, weight does the same thing in artificial neural networks. Is module the weight, so module the signal. After that, this whole thing is going there in transfer functions, and transfer functions. What's happened? It is the information is added with the bias. The formula is given here. Sum of k, this is called the sum of k of transfer functions, is the summations of whole from g is equal to 1 to end for 1 to end a number of neurons for all the neurons. It is added with number of input, whatever the input came, and the input is modeled with the weight. Okay, it is modeled with the weight, and it will added a bias values here. Why it is known as a bias value? Bias is a unique value that is added with the transfer functions to module the input, and it's make the signal robust, and it takes the unique value. Sometimes it takes 0 as well as it's 1 also, but most of the cases we consider the bias values as 1, but you can choose it as a random value as your problem statement. Now, this is the signals. What is the informations? I mean, input come here, input is modeled with the weight, and it is added with the bias. After that, it is a whole signal. Okay, summation, this thing is a whole signal. And the signal is going to the next part of the activation functions. Each of the neurons have their activation function. What happened? Activation functions actually active the signal with some logic. So there is a number of activation functions as of their working principle. They will model, I mean the activation function is model the signal. They will model the signals in a transient, in a sigmoid, in a segment bipolar, in a sinusoidal manners. This depends upon how is the problem works. So this activation function is applied on the summations of the signals, and its summation of the signal is now here. So in the last, there is another thing is we need to consider, that it is called a threshold value. Threshold value, you know, the threshold value you learned in the very early in classes, maybe in the school, around school days. Is threshold value. Threshold value is a value which will decide that it will transfer to the next neuron or not. It will means the signal. The signal will be transferred to the next neuron or not. It depends upon the threshold value. Actually, threshold value is looks as a logic greater than is equal or less than. So suppose the after module the signal with the activation functions. Okay, if the total value of the signal is greater than the threshold value, then the signal will be fired to the next neuron. Understand? I'm repeat the sentence again. If the signal which is the module after with activation functions, this signal's values if greater than or is equal to threshold value of the neuron, then the signal will be fired. I mean the signal will be transferred to the next neuron. Neither no. Neither no means is another way you can say, if the strength of the signal after applying activation function, the strength of the signal is less than threshold value, then the signal will not be fired. I mean will not be transferred to the next neuron. Let's take as an example. Suppose the module signal up to here after playing activation function, the uh, module signals strength module signal of the strength of the signal is like 5, but and the threshold value is given here 4. So obviously 5 is greater than 4. I mean signal value 5 is greater than threshold value 4. I mean signal value is greater than, so the signal will be fired. I mean signal will be transferred to the next neuron. If the signal value is not greater than threshold value, let's now take the example of the signal value of the signal strength is now 3, but the activation's function's value activation threshold value is 4. So threshold value is greater and signal strength of the signal is less. So in this case signal is less than threshold value, so the signal will not be fired to the next neuron. Up to this, I think your concept is clear. Okay, now I'm going to forward. There is another model of neural networks. It's the first model of maculum and pitch model. Sometimes in a flow statement called maculum pitch model. Maculum pitch model of neural networks. It is the first generation of neural networks. After that, we already discovered second and third generations also. So it is the first generation. Let's say there is the only input I1, I2, I3. This is the input, and input is coming, and input is modeled with some weight. Weight may be positive or negative, and weight is calculated here as a sum. There is no bias, no activations, functions, nothing else. That is the first generation neural networks or artificial neural networks. The first one. So from there, the concept is going to increase. Now it is in the third generation successfully. Now it is about the neural network. So come to the next. I will discuss about the artificial neural network connection and architectures. So see, before that, for let not consider the things. Suppose consider the picture. So when the information, suppose the information is coming from that side, it is modeled with like this, and output is coming. So from informations we are getting output. Now consider the picture. Suppose this is an input node. Each of the node is a single neuron. Okay. So let's see, single neuron is connected to the another layer's neuron, and this neuron is connected to the output layer neuron. So there is a 3-layer neurons. Obviously, it makes as a network. Why network? Because each of the node is connected to its next layer node. That's why in the definitions I defined here highly connected. Why highly connected? Because each of the neuron is connected to its next layer neuron. That's why it is highly connected. On the connections, we are classifying the artificial neural network with some architectures. How? As their classifications. 3 architecture is there. First one is feed-forward neural network, recurrent neural network, and feedback or backpropagation neural network. Now discuss about the feed-forward network. What is that? Feed-forward? Feed-forward. Feed-forward means it is passes the signal in a forward manner. Let's see in the picture. Each of the node is connected to each other's of the next near with only single directional arrow. Let's see, single directional arrow. Here also, here also, here also, here. Single directional. That's why it is called feed-forward network. This feed-forward network again classified into 2 categories. One is single layer and is multiple layer. So you can say which layer network it is, single layer or multi-layer. Any idea? Of course, it is a multi-layer feed-forward networks. Why? Because there is a single layer of input and there is a output layers. But Why this layer? This is the extra layer. This is called hidden layers. When input layer is directly connected to the output layer, this type of network known as a single layer feed-forward network. If in between input layer and output layer is there any number of hidden layer is present, then this network is known as a multi-layer feed forward network. So in this case, input layer is this layer, output layer is this layer, in between there is only one layer, so it is a multi-layer feed forward network. But multi-layer means how many layer? Only one hidden layer is this. Why we need the hidden layer? Because if you go the definitions of deep learning, so you can see if we used number of hidden layers in deep learning, okay, deep networks, so it might be possible that you will get the very optimal result rather than shallow network. That's why in the feed-forward network also we are using multi-layer feed-forward networks. And just for small description, I will not go to the very depth. Just learn here that is the hidden layers. Okay. Whatever the layers is in between input and output layer, this one is the hidden layer. It is the first stage of feed-forward networks. Okay. So let's go to the second layer. Second architecture. Second architecture is recurrent neural networks. Second neural network is on this recurrent neural networks. Amazing. So, is there any difference in the features? Obviously, there is a difference. Recurrent neural networks, there is an input layer, output layer in between. Maybe there is a number of hidden layers. So, see, the connection is not same. It does look like forward connections, but from the next layer to the previous layer, there is another connections. This is the architecture of recurrent neural network. What happened? When the information is coming from that side, suppose information is coming up to here, and in the next layer, what it is trying to optimize the error. What error? The error of weight and bias. This error of weight and bias is calculated in this layer, and the weight and bias error value will be distributed to its previous layer to whom it is connected. Let me repeat the statement again. In the recurrent neural networks, a particular nodes or in a particular layers is connected to its previous layers, where it is calculate the error value of bias and weight. The error value of weight and bias is to be distributed to its previous layer to whom the layer or to the node is connected. So it is connected to that previous layer, so the error and bias value will be distributed to here and it will be minimized in like this way. So recurrent neural network also good layers rather than feed-forward neural network. So it is quite complex, but the error minimization is here is robust rather than feed-forward neural networks. Now come to the third layer of features of networks. This is called backpropagation neural networks. In the backpropagation of neural networks, let's see what is the difference. Can you tell me? Obviously. The backpropagation neural networks, it may be possible in between the input and output layer, there may be the possible number of hidden layers will be present. But see, connection is a forward manner and it is the hidden layer and the error signal will be distributed from the output layer towards the input layer. Repeat me, uh, let me repeat this statement. Where connections or the informations is going from forward manner, I mean from input layer to the output layer, but the error distributions will be happen from output layer to the input layers. It is the main concept of backpropagation neural networks. And the error and weight updations change and bias updation change is very popular in these networks, in backpropagation neural networks. So this is three things. Recapitulate the things once again. It is the basic building blocks. Sorry, it is the basic definitions of artificial neural networks. It is the basic building blocks, how they works, and the basic formula. Okay. After that is the first generation of neural network of macro pitch models. After that, we will develop the model up to the third generations, and this is the connections. Connections is depend upon sorry, it is the architecture, and architecture depend upon the neural network connections. As the connections, it is we will classify the architecture into three categories. One is feed-forward networks, that is feed-forward networks. Another is recurrent neural network, that is recurrent neural networks, and another one is backpropagation neural network. This is that one. Now we're coming to the learning of artificial neural networks. So listen this statement carefully. When a neural networks updated its weight and bias value, okay, so and it's training and it's training to something. So obviously the network will learn something. As in vice versa, we can say if we give training to somebody, I mean the person to will learn something obviously. In another way, to learn something, we need to give training, obviously. So, when a network is updated itself by its weight updations and byte updations with different architecture, feedforward, recurrent, or in feedback architectures. So, in this way, what happens? They are actually optimize its error. So when it's optimizes its error, obviously it is learning something. How it is learning? Obviously we are giving some training to the network. That's why it is learning. So on the basis, neural networks or artificial neural networks have three training functions. You can say as well as three learning functions on which they are learned. I mean the network is learned. Let me discuss the three learning functions here. Learning rule of artificial neural networks. How the networks is learned. There is a three learning procedures is there for the network that they can learn. One is supervised, another unsupervised, and the reinforcement learning. These three learning is very important for neural network and machine learning and artificial intelligence also. Very important. If you have the very clear concept about the supervised, unsupervised, as well as reinforcement learnings, then you are now able to take the course of the machine learning or artificial intelligence. I mean, you have the ability to the soft computing artificial neural networks, machine learning domains. You have the ability. That's a very basic concept. You should have to clear the things first. Supervised learning, unsupervised learning, and reinforcement learning. Let's see the descriptions there. Supervised training, as the name suggested, that the training is under some instructor or guidance. It is called supervised training. As we can say the another words, where in a network, input is there and target is given. So the network is trained to itself in such a manner to see the target, it will optimize or it will evaluate its training by itself. It is called supervised training. An unsupervised training where is the target is not given, I mean the instructor or the guidance is not there. It's called unsupervised trainings. Now give me the small example. I think it will clear your ideas. When Albert Einstein is discovered the relativity theory, That times, lots of the places, lots of the invitation is coming to him to give some speech or to deliver some messages to the nations about your relativity theory. So everybody is going here and there everywhere for to give the masses to the nations that how it's how is the importance of the relativity theory. So whenever he is going from one place to another places, everywhere there was another person with him who is always staying with Sir Albert Einstein. He is the personal assistant of PA or PA, I think PA or driver. PA actually personal assistant of Albert Einstein. So what happened one day Albert Einstein is busy with some works and there is invitations. See, he's not unable to go there. So he told his personal assistants to go there and give as you level based whatever I tell in the other places, whatever you know about the theory, give some message to the nations, go there and tell them about the relativity theory. So the assistants came and as is level faced, he tell the like very similar thing to the nations or to the crowds, to the participants, whatever the participants they are waiting for Albert Einstein. So in the first case, when Albert Einstein is giving his thoughts to the people directly, that is called as a supervised trainings. When Albert Einstein is not there, but his personal assistant gives the very similar thing to the nation or to the people or to the waited people, those are waiting for Albert Einstein. Like speech of very similar to Albert Einstein's, but not the Albert Einstein's, that is called unsupervised learning. Learning with supervisor or the guidance, learning without guidance or without target. Now come to the reinforcement learning. What is reinforcement learning? It's the kind of very similar to the supervised learning, but in the reinforcement learning, the environment will take the decisions, whatever the decisions will be acceptable or not. If the decision is acceptable, then the decisions takes as a binary decisions of plus one. If it is not taken, then the decisions will be taken as a minus one. I mean, it will take only two decisions: acceptable, not acceptable, acceptable plus one, not acceptable minus ones. But here, differences from supervised learning networks, supervised learning that or supervised training that in supervised training there is a target is given but in the reinforcement target is not given. The target it will evaluate from its environment. And I will give you the best example of reinforcement training you will never forget. The best example of reinforcement training is playing Ludo and playing chess. I think you know how to play Ludo. In the Ludo, playing Ludo, you will take only one decisions. You will move a particular dice or not. Exactly. Okay. You don't know the solutions. Okay. You don't know the solutions. You don't know the exact solutions that you will win or you will lost. But you will take only one forward directions. You will move or not. You will move or not. You will move or not like this. There is a best examples of reinforcement learning and it's take decision from environment. Why? Because whatever your decisions is always would be changed with respect to your opponent player. Okay, if your opponent player want to lose you, I mean he want to win the match and to defend you, then obviously you will find some of the strategy from the environment. I mean from his movement that you want to you want to win to defend himself or herself. So the decision is coming from environments. With respect to someone who is opponent to you, that's the best example of playing Ludo or playing chess in reinforcement trainings. Today's the fourth lecture. Up to these sessions, now in the another session, next sessions of 5, I will go for the data. To train the data, suppose we need the data first. How, how we'll take the data from where and how and what is the modifications need of the data, how can we understand which one is the input, which one is the output. Those are the dataset related about the informations. We will go for the next video today after these sections. If you have any problem, you will comment me, and I will remember you with the thing again. If those of the body still now not see my first videos to the another video, this sessions, this series of video, please to go through there and please watch the video again. Thank you. Goodbye. Goodbye, and I will remember you the same things again. Please subscribe my channels, like my videos, and press the bell icon for get the notifications. Thank you. Bye.